So this is the last video of this lecture, and in this video, as I said earlier in the previous one, I am going to show you how to confirm that two events are statistically independent. So suppose that you get data, you have a data, or you have a probability distribution table. Then based on that, you would like to check if two events are statistically independent or not, or two variables are independent or not. There are two different ways. First, think about this. When two events are statistically independent, there are two things happen. Like first, as I said, probability of A remains the same regardless of B. No matter what happened to B, the probability of A does not change. That's one thing. And another is based on the special multiplication rule. So if either of them is true, then mathematically A and B are statistically independent. But if at least one of them is wrong, then you say they are not statistically independent. So they are mathematically equivalent. The first equality and the second equality and statistical independence are just mathematically equivalent things. So you have to prove or disprove one of these two equalities, one of these two conditions. That's the main idea. So it does not matter what you use. You just use whatever convenient for you. So I will give you an example. So method 1. Method 1 is based on the first condition. So from the data, you calculate this probability, and this probability, and see whether check if they are the same or not. If they are the same, independent. If not, not independent, right? Intuitive. And actually, you do not need to calculate all three probabilities. Just calculate any pair of them, any two of them, and if the two are the same, then automatically the other must be the same. So just calculate any two of them, any two of these three probabilities, whatever convenient for you. Just and compare them. If you can show one of them, then the two events are independent. If you find at least one is broken, then two events are not independent. Another important thing here is you have to fix the main event here. You are comparing probability of A no matter what happened to B. So comparing probability of A if B happens or B does not, or if it's unknown. So if if you calculate this, something is wrong. You are comparing probability of A and probability of another thing, probability of B. So this does not make any sense. So in this using this method and in this example, a tuition and salary example, you just need to test one of the following six equality. It doesn't matter what you use. Just choose any two probabilities and compare them. But be careful, you have to match the first event. As I said, you may fix the main event as S or T and just calculate any two probabilities. As an example, I'll test if probability of T high tuition equals probability of tuition given high salary. Actually, we already know that S and T are independent. Already we calculated the conditional probabilities, and we learned they are independent. And just as a practice, let's see if they are the same. First, calculate probability of T, which is simple, sum of these two probabilities, because only two outcomes satisfy the event, those two outcomes make 45%. And calculate probability of high tuition among high salary. Among high salary, these guys, and high tuition, T. So numerator is sum of these two, and denominator, sum of these two, numerator 11. So also 45%. They are the same, so statistically equivalent, statistically independent. So you don't need to check the other equalities at all. It doesn't matter what probabilities, what pair, which pair you use among these six. I'm just showing you one example. And now, second method is based on the special multiplication rule. In this case, you calculate this probability and this and this. Calculate three probabilities and multiply these two guys and compare the multiplication and with this guy. If they are equal, then independent. If not, not independent. Also very straightforward. And in our example, probability of intersection is simply one outcome, so simple. And probability of S is sum of these two guys. Probability of T is sum of these two guys. Now, so far it's super easy, but what is a little bit tricky is coming here. When you multiply two probabilities, you have to multiply these two guys, right? 25% and 45%. But when you multiply them, you cannot multiply like 25 times 45. I recommend you to change them to decimal or fractions. So 0.5 times 0.45 gives you 0.1125, and it is 1125, which is the same as the left-hand side. So the special multiplication rule is true, and those two events are statistically independent. As you can see in this example, if you have the probability distribution table like this method should be the same. It should be easier, I think, more convenient, because it's easier to calculate these guys, and multiplication is easier. But I don't like calculating conditional probability like this. This like it's less convenient. So, but not a big deal. But depending on the example or depending on the information you have, you may choose which method you use. So it does not matter method one or method two. Okay. Um, then this is the end of this lecture, and in the next lecture we are going to change the direction. So in this lecture, the first part of chapter 2, we defined conditional probabilities, and we learned how to calculate the conditional probabilities from the full distribution table, full probability table or frequency table. But in the second part, we are going the other way. We have information about conditional probability, and from that conditional probability, we would like to recover the underlying probability distribution. Is that possible or not? Of course possible. So then we learn how to do that. It's also very interesting and very useful, and also very tricky. So look forward to that, and see you later. Have a nice weekend. Bye. By the way, homework 1 is posted, so uh, do the homework as soon as possible. Do not delay it. I give you enough time, a long time, because if possible, I don't want to do the due date. I don't want to set the due date. I just want you to do it whenever you like, but I have to. And so I intentionally set the due date a long time after you I post the video, so that if you delay, then you will be delaying forever, and in the end, you cannot get a good grade because at the end there will be 12 homeworks, and you cannot do them like near the end of the semester. The homework will become much more difficult, take much more time. So it's important to keep doing the homework as soon as possible. And another reason of being having the due date later is because I don't want to accept any excuses. So nearly no excuse is acceptable. Think about this. You have a month for 10 questions, 10 multiple choice questions online. So it takes, maybe I believe it takes less than 30 minutes at most. So uh, there is absolutely no, I think there is no excuse acceptable. Uh, so do not make up any excuses. Uh, okay, good luck and see you later. If you have any questions, I'd be happy to help you. So please let me know. See you later.